Welcome to our mathematics class, Iconic Maths Srihari. Subscribe, share it and like it. Today we are going to discuss some more interesting problems on this coordinate geometry. Right, the first problem on part of that is find the lengths of the medians of a triangle ABC whose vertices are A 7 comma minus 3, B 5 comma 3 and 3 and C 3 comma minus 1, right? See, this is what we have a triangle with the vertices A, B, C like this, right? A, they given it as 7 comma minus 3, right? And B as 5 comma 3 they given like this. And C, they given it as 3 comma minus 1 like this. Now, we want the length of the median from vertex A, okay? The median is nothing but from vertex A, it is nothing but the line segment from vertex to the midpoint of the opposite side. Like let us call this as D. D is what now? The midpoint, like this. How we will get? We know midpoint formula x1 plus x2 by 2, y1 plus y2 by 2. By that we will find the midpoint and we will find the distance between A and D. Then we will get length of the median AD, like that. Now D is nothing but 5 plus 3 by 2, comma 3 minus 1 by 2, like this. Now this is 5 plus 3 by 2, that is 8 by 2 is 4, 3 minus 1 by 2, 2 by 2 is 1. This is now D is 4 comma 1, like, very good. D is 4 comma 1. Now let us find the length of the median AD, like this median is now, it is the line segment from the vertex to the midpoint of the opposite side. Now the length of the median AD, you see here we are going to get length of the median AD, like that. Okay, first let us find all the midpoints and we will proceed further. And FD, this E is the midpoint of AC, like this, right? How you are going to get that also? Let us do that one, my dear students. E, you are going to get it as the midpoint of A and C. This is nothing but 7 plus 3 by 2, comma minus 3 minus 1 by 2. This is nothing but 10 by 2, that is 5 comma minus 4 by 2, that is minus 2, like this, right? This is now BE, right? Fine, right? BE median we can find. How? B vertex we know, E vertex we know that, and this is what E. Let us find like this. Now D, E, F. F is the midpoint of A and B. That how we were going to get it as 7 plus 5 by 2, comma minus 3 plus 3 by 2, right? This is now 7 plus 5, 12 by 2, that is 6, minus 3 plus 3, 0, 0 by 2, this is 6 comma 0. F is nothing but 6 comma 0 you have got. Now you have got CF is what? The median, the third median from vertex C to the midpoint of the opposite side of this we have like this, right? Now we need to find the length of AD, BE, CF. This is what our now job to find this. Now you see how we are going to do this part. Now let us find the median length of median AD. This is now, let us take any one as x1 y1 and the other one as x2 y2. If you take this as x1 comma y1 and this as x2 comma y2, now you apply the distance formula here. This is now x2 minus x1 whole square, square root of it, plus y2 minus y1 whole square. 1 minus of minus 3 whole square, that is 1 plus 3 whole square, that is 4 minus 7 is minus 3 whole square. That minus 3 whole square is nothing but 9 plus 16. Now square root of 9 plus 16 is root 25, that is 5 we have got. And similarly, length of B vertex is this 5 comma 3, E is 5 comma minus 2. Therefore, this is now square root of 5 minus 5 whole square plus 3 minus of minus 2 whole square, that is square root of 0 plus 25, that is 5 we have got. Length of B we got 5, and length of C vertex is this, and F we got the midpoint like this. Now we know these two vertices, we know how to find distance between them. CF is 3 minus 6 whole square plus minus 1 whole square, that is square root of 9 plus 1, that is square root of 10. Therefore the length of the medians we have got 1. Okay, we have got the length of the medians as something like AD we got it as 5 units, and BE length we have got it as 5 units, And another one, the last one, length of the median CF, we have got it as root 10. See, in this way we found the length of the medians. After finding the midpoint, we got all these lengths. Hi, the next one more second problem. It is a very basic problem. We know that they given three vertices of the triangle like this. They given three vertices of the triangle A, B, C. They given, and once they given the three vertices of the triangle in this problem, we need to find the centroid. Already we solved, we proved the centroid of a triangle, right? Let us see here. This is 5 comma minus 1 we will take, and this is nothing but something like x1 y1. And B, they have given it as minus 3 comma minus 2. Let us take this as something like x2 comma y2 like this. C, this is minus 1 comma 8. Let us take this as x3 comma y3. And we know that centroid, see, the centroid is equal to z equal to, we already derived this formula x1 plus x2 plus x3 by 3, okay, comma y1 plus y2 plus y3 by 3 like this, right? Centroid z is, this is the formula, we already derived it. Therefore now this z is equal to, we know that x1 is here 5, okay, plus of minus 3, okay, x2 is minus 3 and x3 is minus 1 like this, minus 1 whole by 3 comma y1 is what, minus 1 plus y2 is minus 2, right, plus y3 is 8 by 3 like this, right? Now if we simplify this, we get, this is 5 minus 3 minus 1, 5 minus 4 1 by 3 this, and minus 1 minus 2 minus 3 plus 8, that is 5 by 3, 1 by 3 comma 5 by 3 are the coordinates of the centroid of the triangle ABC, which we actually, this is what the point of intersection of the medians. You know how we know this D is midpoint, E is midpoint and F is midpoint, means the point of intersection of medians, what you call it as centroid Z. Okay, this centroid Z we have got it as 1 by 3 comma 5 by 3, right? Now the third problem, which is very interesting problem, okay, even though the sentences are lengthy, nothing is here. Let us read out this problem and we'll try to find what they have given and what we want to do in this particular problem. They given the vertices of triangle ABC, right? They given it as A 5 comma 5, B 1 comma 5, C 9 comma 1. They given like this, right? A line is drawn, okay, let us draw, dear students, here like this. We draw this triangle ABC, we draw here like this. ABC is this triangle, and they given that A 5 comma 5 here, right, and B as 1 comma 5 they have given, and C as 9 comma 1 they have given. A line is drawn to intersect the sides AB and AC at P and Q, right? At AB, which is intersecting at P, this, and AC, which is intersecting at Q, and they given that AP by AB. Okay, my dear students, they given that AP by AB is equal to AQ by AC is equal to 3 by 4. Now we need to find the length of PQ. Okay, we need to find the length of PQ means here we need to find the vertex P and vertex Q, right? We need to find the vertex P and vertex Q, right? Therefore, how we will be doing this, you please observe, this is the information they given here, and we proceed now to get the solution part, right? They given AP by AB. My dear students, I can write this as AP by, right, AB we are having here, of course. Of course, we can write this as AB by AP, right? AB by AP is equal to AC by AQ. If you take the reciprocal, that is nothing but 4 by 3 like this, right? And AB, we can write this as AP plus PB, AP plus PB by AP, right? This is equal to, you are having here. And one more thing, AC also you can write it as AQ, because AC is formed by AQ plus QC. AB is formed by AP plus PB. That's what we are writing here. AQ plus QC, right? By AQ. That is equal to 4 by 3 you are having here. Now if you split this, you split, this is AP by AP. That is 1 plus PB by AP. You are having like this. This is equal to 1 plus AQ by AQ. You split plus QC by AQ. This is equal to 4 by 3 like this. Right? Wonderful. Now let us get the ratio now. Now we know that 1 plus PB by AP equal to 4 by 3 means PB by AP is equal to 4 by 3 minus 1 like this. Right? This is nothing but 3 and 4 minus 3. That is 1 by 3 you have here like this. That means you have got AP by PB. AP by PB is nothing but 3 by 1. The ratio 3 by 1 you got. And similarly here you also get QC by AQ is also 4 by 3 minus 1. If you write that this is 1 by 3, right? Right? This you are going to get it as like this. From that you are going to get now AQ by QC. This is equal to 3 by 1. Wonderfully we have got AQ by QC as 3 by 1 and AP by PB we have got it as 3 by 1. That means you see AP, this is 3 is to 1. This is 3 parts and this is 1 part. And similarly this is also 3 is to 1. AQ is 3 and QC is 1. Like that AQ by QC, AP by PB, that is 3 is to 1. Like that we have got this one. Now let us find P vertex. We know the ratio, we know x1, y1, x2, y2, m and n ratio we know. Using that by internal division formula, let us find P coordinates and Q coordinates in the same way we will be finding now. Now how we are going to get P, the coordinates of P are nothing but, m is to n. M is, this is what m is to n like this. 3, okay. Okay, this let us take it as x1 comma y1, right? And this you take it as x2 comma y2 like this. mx2, m into x2 plus n is 1 into x1. x1 is 5 here, right? This is x2 y2 and this is x1 y1. 1 into 5 divided by 3 plus 1. And m y2 in the same way, this what we are going to get. M y2, m into y2. y2 is nothing but here 5, right? Plus n y1. n is 1 into y1. y1 is nothing but 5 by m plus n. That is 3 plus 1 like this. Now P is equal to 3 plus 5. That is 8 by 4, right? And this is 15 plus 5. 20 by 4. 20 by 4. You have like this. That means 8 by 4 is 2. 20 by 4 is 5. Therefore, the coordinates of the vertex P, you got it as 2 comma 5. Right? The coordinates of vertex P, you got it as 2 comma 5. Now let us get the coordinates of Q. This is x1, y1 we will treat, and this we treat it as x2, y2. Therefore, the coordinates of Q is nothing but mx2, m into x2. x2 is what? 9. Plus nx1, n into, this is 1 into 5 divided by 3 plus 1, comma. my2, m into y2 is 1 plus n into y1. y1 is 5 divided by 3 plus 1 like this. Now this is equal to 9. 3 is 27 plus 5, 32 by 4, comma. 3 plus 5, 8 by 4 we have got like this. Now the coordinates of Q, 32 by 4, this is 4 8s are 32, and the coordinates of Q you have got it as 8 comma 2. Now this is okay, the point, this is the point, you have got 8 comma 2 like this. And already we have got P as 2 comma 5. We have got already P. This P is nothing but we have got already this as 2 comma 5. Now you know P and you know Q. Using distance formula we can find the distance between them. From that we will get the length of PQ. Now we know P, we know Q. The length of PQ is nothing but if you treat this as some x1 comma y1 and this as x2 comma y2. Now the formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x2 is 8 minus 2 x1 whole square plus y2 minus y1 whole square. That is nothing but square root of 6 square plus minus 3 whole square, that is 36 plus 9, that is root 45, that is nothing but 3 root 5 units. So because for root 45 you can write it as a 9 into 5, you can write this is nothing but square root of 9 into square root of 5, that is nothing but 3 root 5 units. Okay, this is the way how you will find the length of PQ, right? Now we have another interesting problem come result. This fourth one, use analytical geometry. Analytical geometry means this coordinate geometry only, to prove that the midpoint of the hypotenuse of a right angle triangle is equidistant from its vertices. This is the statement we require to prove, my dear students. How we are going to prove? You see the solution part, how we do this one. You take the coordinate system, like the coordinate axis like this you take, and you know that this is x-axis, right, positive x-axis, and this is y-axis you are having like this, and you know this is what the origin you are having here. Even you can write this is a negative x-axis here like this, and this is a negative y-axis, right? This is what the coordinate system we are having here. They are asking to prove that midpoint of the hypotenuse of a right angled triangle in general, right? We can take anywhere the 3 points of a right angle triangle and we can prove that. But here for easily proving purpose, what I am taking is one vertex, I am taking it as origin, and the right angle triangle formed by this line. Okay, any point on x-axis is of the form a comma 0, right, and any point on y-axis is in the form 0 comma b. Now you have got this is O and this is A and this is B, like OAB is a right angled triangle, right? OAB is a right angled triangle, right? Now they are asking to prove that midpoint of the hypotenuse. Now the midpoint of the hypotenuse, let us call this as C, and we know how to find midpoint of it. That is nothing but here midpoint of A and B. x1 plus x2 by 2, that means a plus 0 by 2, that is a by 2, right? And y1 plus y2 by 2, that is 0 plus b by 2, that means b by 2 is what the midpoint. Now what we require to prove is here you need to prove that the midpoint of the hypotenuse of a right angle triangle is equidistant from the vertices. That means we should prove that OC is equal to this, midpoint is equidistant to the vertices, means we should prove that CA should equal to CB, that equal to CO, like this. Okay, that is what we require to prove. The midpoint of the hypotenuse of a right angle triangle is equidistant from its vertices, means we need to prove that C is the midpoint. Now this distance CO, CA, CB, these all three are equal. That is what we require to prove. How we are going to prove this, my dear students, you please observe. It's very simple that now you know all the four. CO you know, CA you know, CB you know that. You just find their distances and prove that. Now the length of CO, now you take here length of CO using distance formula. That is nothing but A by 2 minus 0 whole square plus B by 2 minus 0 whole square. You are having like this. That is nothing but square root of A by 2 whole square plus B by 2 whole square, like this, right? A by 2 whole square plus B by 2 whole square, we have got it, right? Fine. Now CA, okay, CA distance also we will find. This CA is nothing but what we are going to have is this is nothing but A by 2 minus A. See, x1 y1 and x2 y2, anything you can do like this, A minus A by 2 whole square, right, plus 0 minus B by 2 whole square, 0 minus B by 2 whole square, like this. This is nothing but A minus A by 2 is A square by 4, that is nothing but A by 2 whole square plus B by 2 whole square, we can write because it is okay, however squares of it. Now CB in the same way, if you do that CB, right, minus B by 2 whole square, we can write it as of course this is totally we will write the three quantities now. C B, like if you take this as one as x1 y1 and another one as x2 y2, you are going to have a by 2 minus 0 whole square plus b by 2 minus b whole square, and this of course this is also because it is under square, a by 2 whole square plus b by 2 whole square you are having like this. Therefore, my dear students, here you got this as okay, totally under this C is nothing but CO is equal to CA is equal to CB, and you have got that as A square plus B square by 4. That means 1 by 2 if you take out, this is A square plus B square like this. Right? That means so C is equidistant to O, C is equidistant to A, C is equidistant to B. That means CO equal to CA equal to CB. Very easily you proved using this analytical geometry or coordinate geometry concept. You got this proof. This is a problem come result. Therefore, you see, my dear students, in mathematics, especially in geometry, either it is coordinate geometry or plane geometry, midpoint of the hypotenuse is equidistant to the vertices. Therefore, this only you can call it as circumcenter. Of course, this only we can call it as circumcenter. We can easily, this is only okay. Yeah, you call it as circumcenter. Circumcenter for a right angle triangle will lie on the midpoint of the hypotenuse and it will be equidistant to the three vertices. Now, by taking this as center, you can draw nicely by taking this as center and this as radius. Now, this as radius now. Right, wonderfully you can draw one circle like this. You can draw one circle nicely. It will passing through the three vertices and you call this as a circumcircle. You call this as a circumcircle, right? Okay, that is the information we have obtained from all these things. Now this is a circumcircle with the center as C, this and circumradius is this. The circumradius only, this all these things what we have. This you denote by capital R, of course. R is equal to, you have here CO equal to, see this is what CO equal to CA equal to CB. Right? This is the circumradius, this is the circumcenter. You can draw one nicely circle which passes through three vertices of the triangle. Right. Now, one more interesting problem. The area of a regular hexagon whose diagonal is the join of 2, 4 and 6, 7, then find its area. Right? This is a nice problem. You see, first let us try to understand this problem. What is the information they given? How to get this particular problem. This is, you know that regular hexagon is a hexagon with 6 sides. It is a hexagon with 6 sides you are having here. Right, let us take this as A, B, C, D, E, F. Okay, and they given that see, in a regular hexagon the length of the diagonal become equal. This is one of length of the diagonal, AD or maybe BE or maybe CF. Any one you can take and it is nothing but the length of the diagonal. And they given that one is they given A as 2, 4 and another one they have given it as 6, 7 like this. Right? And you know, my dear students, in this, the midpoint if you take here, the midpoint is nothing but the center of the regular hexagon. You know how to find the midpoint. Let us call it as O. Right? The midpoint you are going to get that as x1 plus x2 by 2. That means you are going to get 6 plus 2 by 2. That is 8 by 2. That is 4. And 7 plus 4 by 2. Right? That is, you are going to get 11 by 2, right? Fine. 7 plus 4 by 2, that is 11 by 2, right? Fine. Now you have got the center of the regular hexagon. Now they are asking to find the area of it, right? To find the area of it. That means it is very simple, my dear students. How we are going to do is, you know that the regular hexagon can be divided into 6 equilateral triangles. See, this one is one equilateral triangle, like, okay, here because this total angle is 360, now this is 60 degrees, this is 60 degrees, this is 60, 60, 60 like this. And here also this is 60 degrees, 60 degrees, you know that. Okay, we need to find area means we need to find the length of right? The length of area of equilateral triangle, you know how to find, and 6 times of the area of the equilateral triangle will give you area of the total regular hexagon, right? You will get the total area of the regular hexagon as like that. Therefore, you see, my dear students, how we are going to perform this is nothing but, now let us find OD length. Like OD is nothing but length of the side of one equilateral triangle, OD, like this. OD is nothing but square root of, right, 6 minus 4 whole square, 6 minus 4 whole square plus 7 minus 11 by 2 whole square, like this, right? OD, one you take as x1 y1 and x2 y2, and this is what OD, okay? Now this equal to square root of 6 minus 4 whole square is 4 plus 7 minus 11 by 2, take LCM, 14 minus 11, that is 3 by 2, and then 9 by 4 you are having here like this. Now you take 4 as the LCM, 4 16 plus 9 you have, now 16 plus 9 is 25 by 4, you have got this 25 by 4, and that is nothing but 5 by 2. This is what 5 by 2, right? Now we got that 5 by 2 is the length of the side of one equilateral triangle means. That means you know that A is equal to 5 by 2, and area of triangle, let us take this as OED, area of equilateral triangle OED. You know that this equal to root 3 by 4 A square. Root 3 by 4 A square. A square is nothing but 5 by 2 whole square. This is now root 3 by 4 into 25 by 4, like this. We have got like this. This is what area of, okay, one equilateral triangle. Now actually regular hexagon, area of regular hexagon. We want area of regular hexagon. This is nothing but this is formed by 6 equilateral triangles like this. This is formed by 6 equilateral triangles. That means this is 6 into, you are going to have 25 root 3 by 8. You are having like, not 8, this is 16 like this, because 4 into 4, 16, right? That means you have got it as, right? We can simplify even this as, okay, 2 8s, 2 3s, like this. That means 75 root 3 by 8 square units, right? Square units we have got like this. How we did is a very simple and basic problem. How we did is they given 2 vertices like this, right? That means this is the length of the diagonal, means the center is nothing but the midpoint of the AD. That's why using midpoint formula we found the center of the regular hexagon, and we know that the regular hexagon can be divided into 6 equilateral triangles like this. If you find area of one equilateral triangle, 6 multiplied to that will give you the total area of the regular hexagon. Therefore area of regular hexagon equal to 3 into 25 by root 3. That, okay, how we have got okay, the length we found OD by distance formula, that is 5 by 2, and area of the equilateral triangle OED is nothing but root 3 by 4 A square. A is 5 by 2 whole square, that you have got 75 root 3 by 16. Now area of regular hexagon equal to 6 equilateral triangle, 6 into that, finally it gives the answer as 75 root 3 by 8 square units, right? In this way you will be doing this particular problem, my dear students. Now what you have to do is, these are some different types of problems we are having here. You please enjoy, and in the next video we are going to give you different types of results, such that you can do the problems in the material, and whatever worksheet is given to you, you can nicely do the problems based on that, right?